Okay, hey everybody, I'm Patrick. Welcome to the live stream. I'm very excited to be here. Today we're going to be talking about acing the coding interview. It's a topic that's very exciting, especially in the new year. You're thinking about making a change in your life. Maybe you want to get your first job as a developer. Maybe you want to change jobs. Either way, I'm going to talk through some tips and strategies today that will hopefully help you in your job search. So for today, I want to break this down into two parts. For the first half, or maybe first quarter, I want to give you a broad overview of what you can expect. If you've never applied for a job as a programmer, it's a little bit different than another job application. So I'll talk a little bit about what to expect as you progress through that process. And then for the bulk of the live stream, we'll work through a problem, some strategies about how to solve that problem, and maybe work towards like an optimized solution if we have time. Cool. All along the way, as always, if you have questions or comments, things that you're curious about, please put them in the chat. We're always looking at it. And I'll try to keep it as interactive as possible. I'm definitely going to throw some questions to you during the stream, so be on your tippy toes. Cool. So to start, applying for a job as a developer. There is the caveat that applying for a job as a developer is like applying for a job in the sense that you want to present your best self. You want to polish your resume. You want to make sure it doesn't have any typos, any of that. But the first step of trying to get a job as a developer is, unsurprisingly, going to be applying, right? You're going to be looking on your job board and you're going to see an opening for a web developer, a software developer, and you're going to send them your resume. A slight addendum to this that I'm going to recommend is if you can do it, try to get some kind of referral. I don't know if I spelled that right. So what this means is you know someone at the company, maybe it's a friend. They don't necessarily have to be a developer, just someone at the company who can vouch for your character, your work ethic. That's really going to help you get a response. So this first phase is probably going to be the highest number. You may be applying to a lot of different jobs, but a referral can really help increase your odds of success in hearing back from someone. So after you send out your job application, usually the first step is going to be some kind of a phone screen. So the phone screen can take a couple different forms. Maybe you'll be speaking with a recruiter. So this is someone whose job it is to vet and evaluate candidates and guide them through the process at the company. Usually those types of phone screens are non-technical, meaning you're not going to be evaluated on your ability to program. It's more about who you are, what's your background, why are you interested in the company, maybe what do you know about the company, the domain it operates in, that kind of thing. There are also phone screens that are going to be technical, and these will usually follow a non-technical phone screen. So in a technical phone screen, that's when you will be paired up with an engineer at the company, and they'll be evaluating your ability to do the job of a programmer. So you may be doing a shared screen exercise where you're typing into an editor where the engineer can see it on the other end of the line, and they're asking you a question, and you're writing out some code to solve that question. A lot of companies will vet this out to a third-party service like Carrot or TripleByte, and it's a very similar idea where you're logging onto a platform, they're giving you a question, maybe they're giving you some inputs, you're writing code to solve it that will output a solution to the problem. Another sort of thing that will come up at this phase is a take-home challenge. So I'll write that out. Call it take-home. Now a take-home challenge is going to be a little bit different, whereas with a technical phone screen, you're talking to the engineer. So there is a time element involved with it. In a take-home challenge, they're giving you a prompt or maybe a package of files. And that prompt is saying, we would like you to build, say a website that can upload photos and display them, or a to-do application, something to that effect. And you are able to build this application in your own environment, somewhat on your own time. Usually they'll give you an expectation of maybe 3 to 5 days. But the take-home is trying to replicate less pressure on you, less time-intensive pressure, whereas a technical phone screen, you're really right in the moment. You're given about 45 minutes to solve that problem. Cool. So assuming you do well in these steps, that's when you move to your on-site. And the on-site is when you're actually coming in person to the company. It's a very exciting moment because you passed a few hurdles at this point. And this is where you're coming in person, you're greeting people. And the on-site will have several different aspects to it usually. A lot of on-sites are all-day affairs or half-day affairs, so it can be somewhat of a marathon. And the recommendation here is do your homework, understand what kind of a company this is, understand who it is they're looking for, what types of things do they value. So for example, at a company like Codecademy, we are looking for people who are very passionate about education and pedagogy and people who care about accessibility in education. So those are things, qualities that we'll be looking for. Every company will be different, obviously. With the on-site, usually you'll also be evaluated on your technical ability, your ability to solve problems. So there may be a situation where they're giving you a problem in front of a whiteboard and you're writing out the code, which is what I'll be demonstrating later in the live stream. There may also be on-sites where you're pairing with an engineer on a computer, so you're both sitting at a computer together and talking through the problem. Maybe you're working on code that the company actually has in production, something to that effect. So this is pretty high level. It's difficult to give very, very specific advice because every company is different, but these steps are pretty much always going to be present. You're going to have to apply or be referred. There's going to be some sort of screening process, which is sort of like an introductory, are you a crazy person? Are you are you the person that we were looking for in this company? And then the on-site, which is a little bit more of an effort. You're coming on site, we're meeting you, probably getting lunch or something like that. Cool. Any questions about that? Again, fairly high level. So one question we got is I've heard read it's worth working through Project Euler. So this is a website of which there are many that provide you with problems that you'll try to solve in the coding language of your choice. Practice, always a good thing. It'll never be a bad thing to practice these problems. Project Euler is a little more math focused, so if that's a domain that you're not as comfortable in, don't be discouraged. Not every company is going to expect you to have that sort of understanding, but it is a great site to practice on. We'll move on now to the actual problem, and what I'm going to do is kind of play both sides of the coin. So what I mean by that is I'll take the place of the interviewer, what they may say, what they may ask of you, and I'll also act as the interviewee and what you can do as an interviewee to help increase your odds of being hired. Cool. So one sort of overarching piece of advice I'm going to give is ultimately, even when you're being evaluated on your ability to code, the most important thing is, do the people that are in the room with you or on the phone with you, do they feel like you're someone they'd like to see every day at work and work with? Are you a collaborative person? Are you a person who communicates well? Do you listen to the things that they say? Do you incorporate the things that they say into your decisions and thoughts? Those are the types of characteristics that are appealing to an employer. If you're someone who is very, very shy, this can be kind of tough, and it might feel a little bit like you're being grandiose or arrogant, but this is really a time to shine. Think about the strengths you have as a person and as an employee, and that's what you're trying to put forward. Great. So without further ado, the question I'm going to be posed is, given an array, you need to find the index where the sum of all values to the left of that index equal the sum of all values to the right of that index. That's our question. So the first thing, whenever I'm asked a question in a technical interview is, it's sort of like a deer in the headlights moment maybe, and what I would always recommend is rephrasing the question. And what this does is gives you a moment to breathe, and it also helps iron out any misunderstandings. So when I'm receiving this question, I may say to myself, okay, what does that really mean? What are they really looking for? Anything that I'm unsure about, anything that's ambiguous, those are the things I want to pose back to the interviewer and make sure that we're on the same page working together. So one thing that can be helpful, especially if you're in a whiteboarding type of environment, is start drawing out examples and say, well, if I have this type of an input, I would get this output. Is that right? Is that what I'm looking for? And that will help sort of begin this dialogue with the interviewer. So if I'm looking for this, we'll call it an equilibrium point in an array, I'll pick maybe like a very basic example here of 1, 0, and 1. Cool. So given this input, I would expect this to be the equilibrium point, because if I look to the left of that index, I'm seeing 1, and if I look to the right of that index, I'm seeing another 1. 1 equals 1. So this is kind of the moment where I'm starting to like flesh out what exactly are you looking for. And there is a little bit of ambiguity here. And so this is kind of a moment where I'll be like, well, are you looking for the value located at the equilibrium point? Are you looking for the index where the equilibrium point resides? Oh, sorry. Switch into the black marker. Just a little tidbit about myself. My favorite color is blue, but it is not the easiest color to see. So my apologies. Let me erase that. I'll start over. So just to kind of recap, what I'm going to be looking for is the index. So maybe that's an ambiguity that came up, and I ironed it out with my interviewer. I said, well, what I really want is that index. So if this array is my input, what I'm looking for is the index of 1, assuming a 0-based index. So we have index 0, index 1, index 2. I would expect 1 to be returned. I'm going to pose a question now back to you. I feel like I've maybe a little bit scoped out this question, but what are some other things that you feel are unclear, or if I were to ask you to solve this question, you would want to know to make sure? Like, what are some other things that could come up, what we call edge cases maybe, that could arise, and what would be expected to be done in that kind of a case? So I'll pose the question to you. Given this equilibrium point question, what are some things you might want to consider? I'll fill in one more while we're waiting. So yes, there is no equilibrium. That's a great one. So thank you, Rob Tuck. Definitely really, really, really great observation. So there may not be an equilibrium point. And again, just to illustrate this, there's no harm, but like, let's say I have 0, 7, 7. So at this point, I don't have an equilibrium point, right? So if I take my sum here, there is no sum. I have 14. I take my sum here, I have 0 and 7. I take my sum here, I have 0 and 7. So I'm never going to reach an equilibrium point with this input. So in this case, I kind of have a conversation with my interviewer. I'm like, OK, well, I know that you'd like me to return an index if there is an equilibrium point. If there isn't, would you like me to return a Boolean? Maybe none, nil, depending on the language that you're working with. Maybe -1 is sometimes used to indicate a sort of non-index position. So great job, Rob Tuck. That's a good one to ask. I have another question for you. Is it possible that there are multiple equilibrium points? So let's say, for example, we have -7, 1, 5, 2, -4, 3, and 0. OK, cool. So in this input, we have an equilibrium point here where we have -1 and -1. And we also have an equilibrium point, I think, here where we have here. Let me do this really quick. That'd be 1 and -1. Maybe we don't have another equilibrium point. I don't know. Do we see it? I think there is another equilibrium point here, but I don't want to like get stuck on this. But in that type of a situation, again, it's a case where I'm going to be talking to the interviewer. Like, do you want a single return? Would you like maybe an array of the indices in that case? And I would work it out with the interviewer. Cool. So in this case, at this point, I feel like we've sort of scoped out the breadth of the problem. Like, what are we really looking for? And now we can start getting into my strategy. Once I know what is expected of me, now is the time for me to have a conversation about how I'm going to go about achieving that. So this is another part that may feel a little bit uncomfortable because you are sort of admitting to a certain extent that you may not have an idea in the moment of how to answer this question. But that's OK. The reality is, working as a developer, you're often in a state of not knowing. So in an interview setting, it may feel really uncomfortable. Like, you want to be the person that always has the answer, that can immediately say, oh, you just do this. But that's not very realistic. So it's totally all right to talk through things. If you have absolutely no idea, and you're totally stuck, even saying that to the interviewer can maybe solicit some kind of a dialogue. The one thing that you really don't want to do is just sort of freeze, sweat, sort of like hem and haw. And I think mostly that, again, comes from the idea that you should know the answer immediately. And that's just an unreasonable expectation for yourself. So I think I've done this a little bit. Let me draw this a little bit bigger in the center so we can talk through it. So we've got -7, 1, 5, 2, -4, 3, and 0. Cool. So here's the array that I'm working with. And when I was talking through my example inputs, I kind of did this thing where I moved through each index and I talked about the sum to the left and to the right. So I'm going to kind of explore that because I feel like maybe that's my key to trying to solve this problem. And if I'm starting here, I kind of have like nothing or nil to my left. And I've got 8, -4 is 4, plus 3 is 7. So I've got 7 here. Then I'll move 1 over, and if I'm looking to my left, I've got -7 here, and then I've got 7, -4 is 3, plus 3 is 6, and so on and so forth. I don't necessarily need to go through each one, but I'm kind of like starting to form out like, okay, so what I really need to do is move through each element in the array, and then somehow I need to take all the elements to the left of that index, sum them up, take all the elements to the right of that index, sum them up, do some kind of comparison. Cool, great. So I have like the beginnings, like my inklings of how cool edge case. A lot of that's true. When I was looking for multiple edge cases, or sorry, multiple equilibrium points, an array of many zeros would have been a great example. So no lack of equilibrium points here. Very nice. Thank you, Julio. Cool. Great. So at this point, like I'm talking through my strategy, and I feel like this is the point where I'm kind of thinking out loud is what I'm doing. And all this time, I'm directing my attention to the interviewer. Like, do you understand what I'm saying? Does this make sense to you? The interviewer may be very engaging. They may be very collaborative. They may be kind of stone-faced. Don't take it personally if they're stone-faced. Maybe that's just the type of person they are. Maybe they feel that to evaluate a candidate, they can't really give a lot. But don't be discouraged and don't stop from talking to them. If you're talking through how you're going to solve a problem to an interviewer and they're just giving you nothing back, that doesn't mean you should stop. Like always present your thinking. You really want to make sure that the person evaluating you has a very clear idea of your thought process because that is a very important aspect of working with someone. You want to know how they think, how they take in ideas, that kind of thing. Cool. So as I said before, I feel like I have a general strategy here for how I'm going to solve this problem. And what I like to do in these cases is give myself like a little bit of a roadmap. So what I'm doing here is trying to offload some of the mental strain on me. I'm a very simple guy. I can only keep so many things in my head at once. So if I have a strategy that works as like a high level, I want to like write it down here so I can refer to it later. And that way, when I'm working through like actually writing out the code, I don't have to be trying to remember what my approach was. So let's say I was going to iterate through the list. I was going to sum all of left, and I was going to sum all of the right. Compare. If the loop is done, then I'm going to return, let's say, none. Cool. So one thing I haven't talked through yet, because hopefully this is something that is going to be clear in the job that you're applying for. When you're asked this type of a question, and it's not evident the language that they'd like you to use, I would just do a quick, hey, I'd like to solve this problem in Python. That's the language I'm most familiar with. Is that OK with you? And I would say 9 times out of 10, I've never been in a situation where they've said, no, do a completely different language. In all likelihood, the language that they're hiring you to work in is probably the language they'd like to see. But if you don't know it, that's fine. Just use the one that you feel most comfortable with. Cool. Just trying to catch up with the chat. OK, great. Cool. So I have my sort of roadmap. This is the thing that's going to keep me on track. And at this point, there's nothing left to do but to jump into coding. And I do kind of want to draw attention to the fact that I've been talking for like a decent amount of time, right? And I haven't written any code at all. And again, that like may at first feel kind of strange, but it is totally all right. Like coding is not a profession where rushing is going to help you. Being able to plan, talk through an approach, these are the things that are going to ensure or at least help you get a solution that has less bugs, that functions the way that you want. So don't be in a hurry to jump to writing code immediately, because it will always help you to take a step back, really think through the problem, how you're going to solve it. Cool. And without further ado, we're going to start writing the problem out. So in this situation, I'm again going to try to keep up this collaborative aspect of it where I'm going to write out sections of my code, describe why I'm writing them out. Again, I want there to be zero room for doubt, zero question about what I'm thinking at any given moment. Cool. So we'll start with def. I'll call it equilibrium point, what have you. It's going to take in LST, that is my list. Great. And what do I want to do when I'm in this list? Well, I want to iterate through it. And as I'm working through the problem, I'm realizing, again, it's good to have an example input. I've had it a few times, but I've also erased it for space. So, and I think 0. Cool. So a little messy. Hopefully people can still see there. This is kind of what I'm going to refer to as I work through it. One thing that I feel like has been a little bit ambiguous, and this is something I probably should have clarified with the interviewer, I'm just going to kind of make a decision right now, is there are times when I was treating the very first index to the left of the very first index as 0. I could also treat it as like none or not even 0. That's kind of a decision I have to make. So as I iterate through the list, what I'm going to do is start at the first index. Because by starting at the first index, I can look for all the values to the left and the right. I feel like, again, this is something that's a little bit like ambiguous, and whatever I came to agreement with the interviewer, which happens to be me in this case, would be the acceptable thing. So I'm going to write my for loop. My iterating variable is going to be idx. I'm going to use my range function. So if you're not familiar with Python, what range is going to give me is a series of numbers based on the arguments passed to range. And as I just said, I'm going to start at 1. And I want to go up until this second to last index. So I will get the length of the index. I'll use the len function, pass in list. And I'm going to subtract 1 from it. And just to recap again for people that aren't very familiar with Python, what this is going to give me is a series of numbers from 1 up until this index here. So range is non-inclusive of the second argument, and I'm also subtracting 1. Cool. OK, and so now that I'm iterating through the list, what do I want to do inside of it? I want to sum all of the left. OK, great. So I'm going to create a variable. I'll call it left sum. OK, and left sum is going to be a sum. So there is a sum function in Python that sums all the values in a list. I will make use of that. And sum takes as an argument a list. And I'm going to pass in a sublist or a slice of the original list. And I want to slice everything to the left of IDX, right? IDX is sort of my marking point of like where that equilibrium point could be. So I'm going to take the slice of everything up until that point. So I will take list. And the syntax for slicing up until a point is I'm not going to put any value on the left side of a colon. And on the right side, I will put IDX. And then I'll close my invocation of sum. So again, what I'm doing here is taking a copy of the sublist, all the values from the very beginning, which is that empty space to the left of the colon. up until, but not inclusive of, the index. Great. So my left sum, we'll do my right sum. I'll do kind of a similar thing. Sum of the list. And now I'm going to slice it in a different way. So one thing, again, it's been kind of implicit, but I want to be explicit about it now. We're not including the index's value in the equilibrium point. So that's being excluded. So in this case, I want to take IDX plus 1. So I want a slice of all the values, one from the right of this iterating index to the very end. And I can denote the very end just with an empty space again, similar to the beginning of the array there. And that will give me all the values to the right of the sum. Cool. So I have my left sum, and I've got my right sum. And now I want to do my comparison. Great. So I'll just say, excuse me, I want to say if left sum is equal to right sum. If that's the case, then I found my equilibrium point. And I want to return the index. Cool. And if that's not the case, if I get through this whole iteration, then I want to return none. OK. So a little bit sloppy. I wouldn't really say that in an interview, but just sort of like being honest with myself, I'd probably want to write this out a little bit neater. Hopefully people can see it. But just to recap what I've done here, defining my function, it takes a list as an argument. I'm going to iterate from this first index to the second to last index. In this iteration, I'm going to get a sub-list of all the values to the left, a sub-list of all the values to the right, and then I'm going to compare them. So I wrote sum and sun instead of sum. If they are equal in value, I'm going to return that index, that iterating index. Otherwise, I will return none. Cool. So at this point, I've written out my code. I've talked through my strategy. I feel reasonably confident that this will work. But you should never be overly confident in an interview. And even if you are, you want to really show that it works. So in this kind of a case, this is why we have our sample input, because now we can kind of put it to the test, walk through each line of code, plugging in this input and seeing what comes out. I've got a little bit of space here, so maybe I'll try to do it there. Perfect. So to start, IDX is going to be 1. We're starting at 1 there. The sum of everything to the left up until it is going to be, let's just do LS for left sum, and we'll do RS for right sum. So my left sum is going to be 7, or sorry, negative 7, excuse me. My right sum will be 7 minus 4 is 3, plus 3 is 6. 6, those aren't equal. So I'm going to increment my index. And now I'm taking, for my left sum, these two values. So that's going to be negative 6. And my right are going to be negative 2 plus 3 is 1. So negative 6 and 1. Those aren't equivalent. Get out of here, you. And we're going to go index 3. So maybe I'll write my indexes down here to make it a little easier. Cool. So everything here. So I've got 6, negative 7. So that's negative 1 on my left. And on my right, I have negative 4, 3, and 0. So that's also going to be negative 1. And ding, 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 we found our equilibrium point. So we're matching this conditional here, and we're returning the index. That's the end of our function. Very cool. I'm super proud of the fact that I wrote a solution. And let me just check in with the questions and make sure we're cool here. Some questions about Python. I'm sorry that I have to use a specific language. I chose Python because I feel like it's probably the closest thing in terms of readability. There's less syntax quirks. We use indentation or white space in Python to denote blocks of code. So that's what you're seeing there. Cool. Some questions about greedy algorithms. I'm not going to touch that because I don't want to get too sort of like down that rabbit hole. I would definitely check out our CS path and the algorithms that we have there. We have a lot more in-depth discussion there. Plug. Cool. Sheet of built-in functions. Yeah. So that's an interesting question. Any function that the language provides you is fair game to a certain extent. If an interviewer asks you, for example, to write like a sorting function and you use an inbuilt sort, that's probably cheating. But most interviewers are going to be happy with the fact that you're using sum rather than like writing a for loop and summing manually. This is really going to come down to your familiarity with the language. And as I said earlier when someone was asking about Project Euler, practice makes perfect. The more comfortable you are with the language, the more familiar you are with the different inbuilt functions, the less time you have to spend thinking about that and the more you can focus on the actual problem. So I wouldn't bring in like a cheat sheet of functions, but that is just something that hopefully you'll become more and more familiar with as you practice. If you're really like stuck and you're like, oh, I just need like a function that can like sum values of a list, then I would be set. The interviewer might suggest, oh, well, Python does have a sum function. There may be something like that, but you can't be like, oh, if only there was like a function that could find the equilibrium point of a list. Like you can't do something like that. It should be like a small piece of the problem, not the problem itself. Cool, great. So we are getting a question about efficiency and time complexity, so that's a nice segue. Thank you very much. So I am going to talk about that. One thing that's a really, really great signifier that you're like a serious engineer, that you care about scale, you care about time complexity, is to talk through the efficiency of your code. So let's just like take a look at what we're doing here, right? We're going to talk about, I'm going to talk about this in terms of big O notation. If you're not familiar with big O notation, we do have an excellent course on it at Codecademy. But I'll give you a very high level, very succinct idea of what big O is. And that's sort of like how much work is our function going to do based on the input it's given. So if I give it a little bit of input, is it doing a little bit of work? If I give it a medium amount of input, is it doing a medium amount of work? If I give it a lot of input, is it giving a lot of work? That would be like a linear time complexity is what we would call that. And in other words, the work scales one-to-one with the input. That's the idea of like a linear time complexity. Like a worse time complexity would be a quadratic time complexity, where I'm doing, the sort of like line of my work rises very steeply rather than being sort of a straight, steady increase. So with that very bad, very high level of big O notation, we're going to jump into analyzing this. So let's take a look at what we're doing here. As someone said, like, what if this input list was like millions of elements, right? Well, one thing I'm doing is I am iterating through each value. My range, I mean, I'm leaving off a value here or there, but for the most part, I'm going to go through each element. And oftentimes in big O notation, we're talking about the worst case scenario. So if I had to do the most possible work this function had to do, what would be required of me? So in other words, if I found the equilibrium point at the first value, that's not really very interesting. If I don't find the equilibrium point, that means I'm going through everything, right? So that's what we're going to consider. So in a worst case scenario, I'm going to go through every value, right? And then I'm summing, I'm making a copy of a list. And so we may be tempted to say, well, maybe this is linear because I know I'm going through every value. But we want to think about what work are we doing for every value, right? Anything that happens in this block is happening for every value in our input list. So let's really kind of drill down into what we're doing. And again, let's just like take this scenario here where we found the equilibrium point. We made a copy of the list. So we made another sublist here that was like -7, 1, and 5. That was our left. That was the copy we made. And then we summed it. And to sum it, you can imagine we're going through every value and adding them together. So we're making a copy, which requires us to go through every value to copy it over. And then we're also going through every value to sum it together. And we're doing the equivalent on the right side. So we also have a list that's like -4, 3, and 0. And so what we can see here is we're kind of creating a whole new version of the input array. It's a little bit smaller because we're excluding that middle value, but otherwise it has as many elements inside of it as our input. And in big O notation, we talk about the input as n, usually, like a big N. So what I'm doing inside of the loop is could also be considered n work, or a linear amount of work. Putting that together, for a linear amount of work of iterating through each element, I'm doing a linear amount of work. So n times n, I'm doing it multiple times, so that's not great either. But the time complexity for this is actually going to come out to n squared. O of n, I'll write it out there. And again, n is the length, the number of elements in our list. So not great, not like our ideal efficiency. And so if what we just covered feels a little bit like, whoa, like this seems like a lot, don't be discouraged. I wouldn't say that this is the end-all be-all of doing well in a technical interview. Ultimately, you're being hired to implement business logic, build applications, build features. So if you're someone who's really passionate about coding and you can come to solutions, that is a really, really good accomplishment and something you should be proud of. This is sort of like the icing on the cake, the real nice way to distinguish yourself, talking about time efficiency, but don't discount this work. Getting to this point to be able to write out this type of a solution is really great. Cool, awesome. So at this point, yeah, I think I'm trying to think of how much time we have, and I feel like we could probably code up a more efficient solution. So let's do it. And what I'm going to do is take this work here. I'm going to erase it. So now we're going to dive into like, OK, I want to write a more efficient solution for this problem. I'm going to sort of undo the code I've done. Because at this point, I've sort of satisfied to myself and hopefully to the interviewer that I can code up a solution to this. But now my challenge is I want to do a better job. I want to make this more efficient. And when doing a more efficient solution, I find that like a general helpful strategy is how can I eliminate repeated work? So to put this another way, when I was analyzing the time complexity, I was summing up these sublists. And I was summing up the sublists multiple times. I was making a copy of -7. Then I was making a copy of -7 and 1. Then I was making a copy of -7, 1, 5, and so on. But -7 and -7 and 1 aren't all that different, right? Like it's just one more value. So do I really need to copy over and sum over all these values every single time through my loop? That's my way of thinking of like, maybe I can reduce that complexity. This is definitely, again, a little bit more advanced. And if this feels like a little discouraging or hard to grab, that's totally OK. This really comes with like a lot of practice. I've been doing this for several years. So again, don't be discouraged. But what I want to do is remove that repeated work. So one thing I have to do is I have to iterate through the array. Like I have to go through the array to find out where that equilibrium point lies. So I'm going to have a for loop. I know I'm going to do that. So I'll do for idx in range range length of the list. Great. Cool. So I still need my loop. But now what I'm going to do is I'm going to sort of create a running tally. And I think someone talked about like a greedy algorithm. And this is kind of like moving in that direction of like the idea there. What I'm going to do is I'm going to create a sum, which is the entire sum of the array. And I'm going to create a sum that's like no elements in the array. And then I can make small changes to each of those values as I move my way through. And in that way, I won't have to do a sum for every iteration of the loop, and I won't have to do a sub-slice of every iteration in the loop. So what I'm going to make is a left sum. And my left sum is going to start out as 0. And I'm also going to make a right sum. And my right sum is going to be the sum of the list. So basically everything, right? And what I want to do now is in my loop, I want to add to my left sum. I want to check whether my left sum equals my right sum. If it does, I found the equilibrium point. We can all go home. Or I want to subtract from my right sum. Cool. So let's move through this again. OK, cool. I think I'm doing this correctly. If I'm not, feel free to call it out. What I want to do is take my left sum. And I'm going to add to it the value in list located at index. So LST IDX. Cool. Then what I want to do is check if the left sum is equal to the right sum. If it is, I want to return the index. If it isn't, I want to kind of set things up for the next iteration of the loop, and I need to subtract that value from my right sum. Otherwise, my left sum is going to build up, but my right sum isn't going to go down. So I'm going to subtract from my right sum minus equals the value at the list at that index. Cool beans. And then out of 4, if my loop concludes, I'm going to return none. Great. Cool. Again, like I'm kind of like moving through this quickly because I don't want to keep everyone too long, but I think we can wrap this up in the next couple minutes. So I feel good about the code I wrote, but again, it's not about you feeling good. It's about showing that it works. So we're going to step through with the input and see how this goes. Just like before, I find it's really helpful to like diagram out the variables that you're working with, just to like really like have it all out there. I don't need to keep it in my mind. I can just refer to it on the board. So I've got my index. I've got LS will be my left sum. And I've got RS, which is my right sum. So unlike the previous solution, I'm starting at the 0th index. So a little change there. So index 0. My left sum is starting as 0 as well. And my right sum is the sum of the list, which is -6, -1, +1, -5, -2. Doing math on the spot, not my most strongest suit, but I feel I'm doing pretty well. Cool. So we're starting with, the first thing we're going to do in our loop is we're going to add to the left sum of -7. So my left sum is going to become -7. Then I'm going to do my check. Is -7 -2? No, it's not. Then I'm going to subtract from the right sum. So I'm going to subtract -7 from my right sum. -9. Wait. Yeah, I think that's right. Cool. And then I'm going to go back in the loop. Now I'm at index 1. Cool. 1 is my value. I'm adding to the left sum, so that's going to become -6. And I'm going to check, is -6 equal to -9? No, it is not. And so I'm going to subtract from my right sum of -1, so that's going to become -10. I'm going to 2 now. Cool. So adding to the left sum of 5, so this becomes -1. Are they equal? No, they are not. The right sum is going to get subtracted of -5, so that's -15. This does not feel like I'm moving towards the right solution here. I think there's a bug in this. What have I done? Oh, yeah. Yeah, nice. OK, cool. So thank you very much for helping out in the chat. My initial summing of the list was incorrect. So -7 plus 1 is -6, plus 5 is -1, plus 2 is +1, minus 4 is negative 3, and plus 3 is 0. So again, folks, just goes to show that mistakes happen, and that's totally fine. The good part is that we were able to get to the bottom of it. And also, this kind of illustrates the benefit of why you want to walk through the code that you wrote with these inputs. So in this case, when I was doing my demonstration, that's where the mistake came in. But again, mistakes happen. It's OK. Let's start this over really quick. My apologies. So my left sum, wait, all right, hold on a second. 0, 0, and the sum of the list is 0. So yes, so great. So a little confusing. We're back on track. My index is 0. I'm going to add to my left sum at that index, so my left sum is going to become negative 7. They're not equal, so I'm going to subtract from the right sum, negative 7. Cool. I'm going to add to the left sum 1, so that is negative 6. They're not equal, so I'm going to subtract from the right sum, negative 8. I'm going to add to my left sum 5, the next value, so that becomes negative 1. Subtract this, that becomes negative 13. Did I do this correctly? Negative 7 is plus 7. All right, at this point, I feel like I'm trying to rush through a more efficient solution, which is probably not the way to go about this. So I'm sorry to end on such like a disappointing note, but I feel like at this point, you'll have to make the evaluation of whether you're going to hire me or not. I could try to debug here. I don't know. Do people want to see me debug this? I feel like I'm pretty close.
We have some good questions.
All right. I'll jump through the questions.
Would it be safe to assume that the difficulty of the questions for the onsite would be similar to those for prior stages of the interview process?
OK, cool. So the question is about like how difficulties progress. I would say in general, at least in my experience and the people I've spoken with who have done it, just need to debug math skills. It's true. I would say that the time spent in the onsite is more significant than the time spent during the phone screen. So in that case, you're going to be expected to be talking about how you code through solutions or the problem on the onsite. I don't know necessarily that the problems become more complex or more difficult, but there is more time devoted to evaluating you as a candidate. So in that sense, you will sort of be evaluated a little more strongly in the onsite than the phone screen. Any other questions?
Just generally, what do you do when you make a mistake?
Yeah, generally what you do if you make the mistake, as I literally just did in front of you, is first of all, it's not the end of the world. Like mistakes happen. Everyone makes mistakes. The most experienced professionals make mistakes. The most neophyte beginner makes a mistake. I think what you can do is acknowledge that and move forward. Now, in this case, I'm trying to like wrap up this, so I'm not really going to go into a debugging mode. But in the interview, like I'm going to be talking with an interviewer. He's maybe going to help point me towards the solution. Yeah. I mean, again, like I don't want to go down the rabbit hole of debugging it. But I think the important part is to acknowledge that you made the mistake. Talk about why that mistake happened. So, for example, and the first time I was like, oh, right, the sum of the list isn't negative 7 or whatever I said it was. It's actually 0. That's where the mistake happened. So you're sort of showing the ability to diagnose why you went wrong and what you can do to get back on track, which is debugging. Again, it's a very valuable skill. If you don't pass the test, so that's a good question about passing the test in the phone screen. So some screens, especially if it's like a third-party screen, there may be like a number of tests you have to pass, like literal like red, green tests. Usually you need to pass those or at least a good amount to proceed. If it's a problem you're working through with another engineer, it's going to be a little bit more subjective because there's that human element in it. But again, in those cases, usually you at the very least have to find some kind of a solution. So if I'm diagnosing my own interview right now, I would be like points for being able to come up with the more naive implementation. He struggled with the more advanced version of it, but I think he was on the right track. So in that case, it really comes down to like the company's needs, evaluating against other candidates. Like going back to making mistakes, I think that's another important thing to keep in mind is you're being evaluated based on the other candidates. You're not being evaluated based on a sort of like perfect human being that can answer everything perfectly instantaneously. You're only going to get hired or not hired relative to other people. Cool. Yeah, so I would say that the computer science path starts you off with fundamentals of Python. So if you don't have a lot of experience, that's totally okay. We'll teach you through the very beginnings, the building blocks of the language, and we'll get you all the way up through more advanced algorithms and data structures. If you completely go down the wrong path with a solution, so this is a good question. Again, Rob Tuck, thank you. I would say that this is somewhat dependent upon the interviewer, but in general, I think it's helpful to imagine that interviewers want you to succeed. If you do a really good job in an interview, that means the interviewer doesn't need to see other candidates and they can fill the need they have at their company. So if an interviewer sees you going down the totally wrong path, like that is not correct, they probably are going to speak up and say something. I don't think it's helpful to think of interviewers as like vindictive people that want to see like struggles. In my own experience being an interviewer, I want to see people succeed. I want to help them as much as I can without sort of tainting the evaluation of them as a candidate.
How do you then recover from that as an interviewee of like, oh, I went down the wrong path and they like got me back on the right track? What do you do?
Gotcha. Yeah, I think if you go down the wrong path, then you could sort of then in the moment try to diagnose like, okay, I went down the wrong path. In my strategy, I was including, for example, the value that I was supposed to be finding the equilibrium point, and that was preventing me from finding it. So, that was how I made my mistake. And now I'm going to rectify that mistake by leaving it out of my calculations. So I think again, it kind of goes back to like trying to self-diagnose, articulate what went wrong and how you can find a solution for it. Like, okay, this was a mistake I made. Here's why I made that mistake. Here's what I'm going to try now. More interview prep live streams. I'd love to do them. Hopefully I can come up with them more. I really feel like this works. There's something wrong here. It's going to drive me crazy. But yeah, I would love to do this more. So if people are interested, let me know. Great. I think at that point it's been almost an hour, so I'm going to put a button on it. My kind of final thoughts are, for one, like don't be discouraged. Finding a new job, especially in a new field, is very difficult. I don't say that to be discouraging. It's more like this is the road ahead for you. And like any goal that's worth having, it's going to take some effort, but you can absolutely get there. The keys are putting in the practice, having patience with yourself, being able to appreciate where you've come, even if you're not quite where you want to be. Like personally, I'm proud of the fact that I could come up with something in the moment, even if I wasn't able to like totally ace this. But those are the main things. And again, like communicate with your interviewer, talk to your interviewer, try to build a rapport with them, try to build some kind of a relationship, because that is one of the people, they're one of the people who are going to be making a decision about whether to hire you or not. So even if you come up with like the perfect solution, but you never talk to your interviewer, you never tell them what you're thinking, it's going to be kind of hard to give that person the green light because you just don't know what they're going to be like to work with. And that's a very dicey situation. Cool. Thanks so much, everyone. I really appreciate your attention and have a good one. Good luck with your job interviews.